In this lesson, we are continuing to solve rational equations and simplify rational expressions. The difference in this case is that we're going to be doing both in order to solve the problem. So for instance, if you take a look at the problem currently up on the screen, you'll notice that we actually cannot start by cross multiplying like we would when solving a lot of these rational equations. And the reason is because over here on the left side, we don't have a single fraction. We need that to be a single fraction before we can cross multiply. And for that reason then, the very first thing we need to do is actually do that addition on the left-hand side. Now, the nice part about doing it in this particular problem is that we already have a common denominator, which is going to make that whole process a lot easier. So if we're going to add 1 over x plus 2 over x, that then just becomes 3 over x. And of course, it's still equal to 1/4, the same thing, because we didn't change anything on the right side. But now that I have just a single fraction on each side of my equation, I now can cross multiply. So I do the 1 times the x, which gives me x, and I do the 3 times the 4, which gives me 12. This one is very convenient. After having done that multiplication, I have x equals 12. I have what x equals, and therefore I am done with this one. So that problem is now complete. Now we move on to another problem. It doesn't look too much more complicated than the last one, but you'll find it actually does end up being quite a bit more involved, as we'll see. And oftentimes we just have to start working the problems to see where they take us. So the first thing we need to do is, again, we need to actually get this to be just a single fraction on this side of the equation. So we need to do that addition, which of course means getting a common denominator. Right now my denominators are 2 and x. Well, the only way I'm going to get a good common denominator out of that then is by multiplying them by each other. So I'm going to make 2x my new common denominator. And remember, in order to get there, if I have to multiply the 2 by x, I also have to multiply the top of that fraction by the same thing. And on the other fraction, if I have to multiply the x by 2 on the bottom, I also have to multiply the 10 by the 2 on the top. Remember, whatever you multiply the bottom by, multiply the top by the same thing. Once I've done that, I can now go ahead and add my two fractions together to make a single fraction. Now, of course, if I'm going to do x plus 20 on the top there, well, that's just going to be x plus 20. I can't combine those terms in any way, and so they just have to stay x plus 20. And of course, it's over 2x. The denominators have to be the same because they stay the same. Now that I have a single fraction on each side, now I can go ahead and cross multiply. When doing that cross multiplication, remember, when you multiply the 2 by x plus 20, you got to distribute that 2 to both of them. So you got to multiply the 2 by the x and the 2 by the 20, which is why we end up getting 2x plus 40 there. And then when we cross multiply the other way, we end up doing 2x times x. Remember, x times x is x squared. All right, now that we've cross multiplied, we're basically done with the rational equation part of solving here. We now are at the point of just solving the resulting equation. And at this point, we always have to just look at the resulting equation and think about, what does the current form of the equation tell me to do? In this particular case, because my equation has that x being squared in it, it tells me that solving it is going to mean solving it as a quadratic, which means setting it equal to 0. And then try to factor it, or maybe use quadratic formula, something like that. So, since I'm going to be solving this quadratic, I do want to set it equal to 0. I do always like to keep my x squared term positive. And so, now that I'm here, I'm going to go ahead and move the 2x and the 40 to the other side. And so I'm going to start by subtracting the 2x from both sides. Then I'll subtract the 40 from both sides. And I now have my quadratic set equal to 0. Whenever we do this, we want to try solving first by factoring. Now, in factoring here, you'll notice that I can, in fact, factor a 2 out of every single term. So I'm going to start by doing that, because it's going to make any other factoring I do much easier. Now that I've factored a 2 out of every term, I look at the resulting quadratic on the inside, and because it's just a plain old x squared, the factoring process should be easier. In this case, I'm saying what two numbers add to a -1 and multiply to -20. That would be -5 and 4. Notice the 2 that I factored out earlier, it's still hanging out front of those parentheses. All right, I now can solve from here. And remember, the whole idea behind factoring is that we need it equal to 0, because if I can make this x minus 5 equals 0, then that times all the rest of it will still be 0, because 0 times anything is 0. So I'm going to do x minus 5 equals 0. And then similarly, I'm going to end up doing the x plus 4 equal to 0 and solving each of those. When I do that, in this case, I end up getting x equals 5 and -4. We ended up with two solutions. And we ended up with two solutions because this was a quadratic. Of course, if it ended up just being linear or something like that, that'd be a different story. We are now going to work one last problem here together. Now, this one's got a couple different little wrinkles in it, as you'll see. Definitely a great one to make sure you get down in detail and notice some of these little things that we talk about as we go. So, of course, be writing it down and taking notes as we go. All right, so the first thing, of course, that we need to do is we need to get just a single fraction on both sides, which means I need to do the subtraction on the right side. Now, of course, in order to subtract fractions, that means I again need a common denominator. In this case, to get that common denominator, the only way to get it is by multiplying our two denominators we started with by each other. There's no other way to find a common denominator in this case. For instance, there's nothing I can multiply this denominator by to turn the 2 into an 8 while still leaving the x as an x. And so really the only way to do it is by multiplying them by each other. So that means I'm going to have to be multiplying this first fraction by x plus 2. Top and bottom, remember. And then the second fraction, I'm going to have to multiply top and bottom of that one by the x minus 8. And of course, whatever I multiply the bottom by, I multiply the top by the same thing. And then I need to multiply those through. Now, when doing that multiplication, we always have a choice. Do I leave it in factored form, or do I expand it here and multiply it out? Either way would work, but because I know where I'm going with this problem and I know some of the other things that are going to come up along the way, I'm going to go ahead and put them into expanded form. I'm not going to leave them factored in this case. But of course, if you did leave it factored, then at a certain point you'd realize, oh wait, now I have to multiply it out, and you would at that point. So when I multiply all those through to get my common denominator, here is my new rational equation. Now the nice part is on the right side, I do now have a common denominator, so I can do the subtraction. So of course the left side, it'll stay the same, but on the right side, when I do that subtraction, I want you to be very careful here. You have not had to do many, if any, questions involving subtraction with the rational expressions, because you really have to pay attention and be very careful about one particular aspect. When I subtract on the top, the tendency is to do 5x minus 3x and then 10 minus 24. But that would be wrong, because you're actually going to be subtracting the 5x plus 10 minus the whole 3x minus 24. Notice this minus is out front of the parentheses, which means, yes, I am doing the 5x minus 3x, but it also means I'm going to be doing 10 minus negative 24, because we are going to be doing minus the negative like that. And so that is something to be very cautious about. Whenever you're doing these subtraction ones, make sure you are in fact subtracting both, even if it means you're subtracting a negative. All right, so now that we've seen that that's what we need to do, let's actually do that subtraction. Now that I've done that subtraction, I now have my fraction equal to a fraction. That means I can now cross multiply in order to be able to get rid of all the fractions. Do remember, keep those parentheses in there when you do that. So you're going to be multiplying the x plus 2 times 2x plus 34, which means you got to multiply everything in that first parenthesis by everything in the second parenthesis, and then combine like terms. When you do that for that particular one, you end up with the 2x squared plus 38x plus 68. Of course, the other cross multiplication, doing 1 times x squared minus 6x minus 16, that one's easy because we're just multiplying it by 1, which therefore means it stays the same. All right, we've now gotten rid of the fractions. We now need to solve. We let our equation tell us how we solve it from here. In this case, we have another quadratic, and therefore, once again, I am going to be addressing it as a quadratic. If it wasn't a quadratic, let's say it was linear, well, then I would just move the x's to one side and the numbers to the other side. But because it is a quadratic, I want to set it equal to 0. Now, when I do that, I do like to keep my x squared term positive. And so for that reason, planning ahead a little bit, I'm going to want to move this x squared from the right side to the left side, which means I'm going to move everything from the right side to the left side and make my 0 on that side. So I subtract the x squared from both sides, I add the 6x to both sides, and I add the 16 to both sides. And here is my result. Now, hopefully I can factor it. If I can't factor it, I will use quadratic formula, but I'm hoping I can factor it first, because that's going to be a lot easier. In this case, I would have to find two numbers that add to 44 and multiply to 84. Is there such a pair? Yes, there is. Yes, that is factorable. Now, it's not our normal like numbers between 1 and 12 where they often tend to fall for factored forms. However, we can use a combination of 42 and 2. And so, now that I have my factor form, I can solve. Remember, it's set equal to 0 because I can set both parentheses individually equal to 0. So I'd be saying what plus 42 equals 0, and then what plus 2 equals 0. That gives me negative 42 and negative 2. And so that one would be done. Now, a little bit of a sidestep here. I want to bring something to your attention, but it's not something that I'm going to be expecting you to do and use today. But I at least want to put it on your radar. One of these two answers works, and one of these two answers actually does not work. Technically, that negative 2 is an extraneous solution. The reason is, if I plug these two numbers back in to the original equation up here, the negative 42 would end up giving me the same thing on both sides. But if I plug the negative 2 in for x, so I'm just going to go ahead and write in over the x's there just so you can help visualize that I'm putting that negative 2 in for x all up here. Notice that in, for instance, this first fraction here, I end up doing 1 over negative 2 plus 2. Well, negative 2 plus 2, of course, is 0, so that would be 1 over 0. We can't do that. We cannot divide by 0. Anytime you would end up dividing by a 0 in a math problem, something bad has happened. Either it means we have to create some sort of exception or restriction in the problem that says it works except for this one, or it means we simply cannot do it. This is one of those cases where there's a restriction on it that's underlying some of the work we did. In this particular case, if we got an answer either of negative 2 or a positive 8, because that would make this divide by 0, either of those two answers wouldn't have worked. So technically, the only answer is negative 42. But again, am I expecting you to know that and be able to use that in like our assignment today? No. But I am wanting to put it on your radar so that you're aware that that can happen and that it is something to be thinking about as you go forward, because more and more as you deal with rationals, you will eventually be expected to know and use that information.